To sketch this, I need to find all the key features, starting with, well, we can start wherever we want, but let's start with vertical asymptotes, which are going to make me divide some number by 0, divide my cookies into tiny little crumbs, which will take me to infinity. So what's going to make me divide by 0? Well, it would be x equals 3. Okay, what's going to make my numerator 0? And 0 divided by something that's not 0 is just going to be an output of 0, which is the definition of an x-intercept when the output is 0. So that happens when x equals -4. I also have the other factor, which is x minus 1 over x minus 1, which is causing a hole at x equals 1 comma, what's the y value of that hole? Well, I'm going to plug into the polynomial, or sorry, I'm going to plug into the rational function with the x minus 1's canceled. So I'm going to plug in 1. So I get 2 times 1 plus 4 over 1 minus 3, which is going to be 2 times 5, which is 10, divided by -2, which is -5. So I have a hole at 1 comma -5. All right, and then what else do I need to find? How about a horizontal asymptote? That happens at y equals 2 because I have a degree 2 polynomial over another degree 2 polynomial. So those are comparable in size. They cancel each other out at infinity, just leaving 2. Okay, last thing, let's find the y-intercept. Y-intercept by definition is where the input x is 0. So it happens when x is 0. What's y? Well, let's plug in. We get 2 times 0 plus 4 over 0 minus 3, which is going to be 2 times 4 is 8 over -3, so we have -8/3. All right, so now we have all the information we need to start graphing by putting the key features on here. So let's put on my vertical asymptote at 3. Okay, let's put in my x-intercept at -4. Okay, hole at 1 comma -5. So 1 comma -5 would be like down here. Y-intercept happens at 0 comma -8/3. So that's going to be like about -3-ish, right? So it's going to be above -5. Okay, about right there. Okay, we have a horizontal asymptote at 2, so let's put that in. And that's all our information. Now, again, what do we know here? We know that these all are connected. And if they're all connected, there's no way this is just going to pop back up like this because there's no x-intercept there. Similarly, we can't just like come down like this. We must approach the HA. So here's this side of the graph. Oh my gosh, come on. Let me draw this. There we go. All right, and then again, multiplicity of the asymptote is 1, so we must be approaching the other infinity on the other side of it, and then we're going to approach the HA over time. So there is our sketch of this function.